Welcome guys. So today we'll see how we can create a Hindi NER model using Spassy, and for that we'll download a Hindi dataset and we'll try training that dataset on Spassy. So when I downloaded the dataset earlier and checked through it, I found many mistakes in it. So I was just checking, is there any data-centric tools available to help improve the dataset, and I found one. So before we get to that tool, first we'll see how we can train a Hindi NER model using Spassy on a Hindi NER dataset. So this is what this video is about. So this is going to be a large project, so this would be divided in parts. So we'll be shooting each part, we'll be recording each part separately. So today we are focusing on these 15 items where we will check the dataset, download the dataset. The dataset is in a JSON format, in a custom JSON format, but the tagging is, even though it's in JSON format, the tagging which they follow is IOB tagging. So we will convert that JSON dataset with IOB tagging to a proper IOB dataset by writing a script. And then like that dataset, that particular dataset, I think has around 1 million records. That is around 10 lakh records, and so that would be too much for my system to train upon. So I would take out first 15,000 records for training. So we will fetch 15,000 records for training, and then we'll, like I said, I found an data-centric NER tool which helps in improving the quality of dataset. So we will use that tool and see how we can train and create and train a model and then improve upon the dataset. So these are the agenda which we will be covering today. So let's move to the next item, which is introduction to dataset. So the dataset which I was talking about is made available for everyone by AI for Bharat, and they have a lot of dataset made available for using which you can train your own models. So if I go to AI for Bharat datasets, so these are all the datasets which are available by AI for Bharat, which you can use to create your own models. So the NER dataset is available in naamapadam folder. So I'll open this. So here they have mentioned that naamapadam is the largest publicly available NER dataset for 11 Indian languages. So right now we are looking at Hindi. So, and it has 3 entity categories: person, location, and organization. Okay, and it has train, test, and dev splits, and they have also released an multilingual mbert model called Indic NER, which is fine-tuned on the naamapadam dataset. Okay, so let's head out to the dataset in Hugging Face repository. So here so here is the dataset preview. So like if I go to the Hindi dataset, so here like it's here it's shown a different way, but I'll go to files and versions and go to data. Here I can download the, I'll copy the link address and I'll go to my terminal. I'll make a dir Hindi NER. Okay, here I make a sorry cd Hindi NER mkdir dataset cd dataset. Here I'll do a wget with the continue option. Yep. So the data set is downloaded. I'll unzip the data set. Okay, what's the error here? It's saying end of central directory signature not found. It's an HTML document. Oh. Oh, is it? Oh, I should copy this link address, or should I copy this? I think this is the right one. Okay, let me just clear the terminal and download the proper data set. Okay, now I'll unzip it. Again, the same problem. Okay. With the same thing. Yeah, now I think there is some content which is being downloaded. Okay, so let the data download, then we'll unzip it. Yeah, let me check. Yeah, so we will unzip the data set. Okay, so we have 3 files here. Yeah, let it be. We have a 470 MB train.json, 6.5 MB validation JSON, and 185K test. Okay, so let's see how does our data set look. So here these are individual JSON lines. So this is a JSON-L format, and the JSON format in itself has words and then their corresponding NER tag. So each word has a corresponding IOB tag. So here it's O. For sector it's O, 55, 56 is again O. Similarly, K is O, SHO is O, and then we have a begin person, and then we have immediate person. So Arvind Kumar is a person. Okay, so now what we will do is we will convert this into a proper IOB data format. Okay, so for that I will convert AI for convert AI for Bharat JSON to IOB dot py. Let's convert that. Okay, so first thing what I can do is import the sys package simply so that I can take my input file from the system argument. Okay, now what we can do is with open in file comma r as my file pointer, do is it was a JSON L, right? So we have for line, each line in F. Now my record was a JSON, so I need to convert the JSON dot load as. Yeah, this will convert my JSON. So oops, so since J comes before S, we'll import JSON first. Okay, so now we have our record. Now let's see, we have less I train.json. Okay, we have words and we have NER. Okay, so what we would need to do is, for each word in our words record, we need to get the tag from the NER list. Okay, so for that, what I would need to do is, for word in record of words, yeah, but what I would need is also the index. Okay, so what we can do is, for index comma word, we can enumerate our list of words. Yeah, then what we can do is, we need to get the ith record from NER. So our tag would be record of NER of I. Right. So shall we try printing our word comma tag? Okay, so just let me run this. Three, and I can pass in my train. Oh yes, it looks IOB. Bengal. Yeah, here Uttar Paschim Frontier Prant. Okay. Balochistan is begin location, then Uttar Paschim Frontier Prant is a single entity. This looks good. Okay, so back to our now what we need is an output file to write our output records to. So we will add out file equals sys.rv of u. Okay, then what we can do is open out file in write mode as out. Okay, so now we have our out file, and now what we need to do is, we need to here out dot write, what we need is word, a tab, and our tag. Okay, so and a slash n too. So let's create a list of what we need. We need our word, and we need a tab. Okay, and then we need our tag, and then we need our slash n, new line character. Okay, we need this, and we need to join that to a string, so we'll use join. Okay, so we have our word. Does this look good? This looks good, right? Right. Okay, so this would enumerate a single sentence or a single record. Okay, so after this, what we would need is a new line character, so that we have okay. So before we test, I think we should add a count so that we don't parse the entire file. So let me add a count, and for each line I will increment my count. And I'll out that right, and if I'll just write if count is greater than equal to 10, then just sys.exit. Let's see. So here we say test output dot iob. Okay, now let's see our test output dot iob. Okay, it looks good. Begin person. Then there is a gap here. Okay, let me open it in vi, or rather vim maybe. Let me enable line numbers. So here till line number 30 we have a sentence, and then our second record is starting. Yeah, so this also looks good. So far so good. Now what we can do is we can add doc start so that our individual records are considered as a record. So okay, let me write out dot write. So there's a fixed doc start format for Cornell 2003 and IOB file formats. So I think this is doc start with the tab and then tag O with 2 lines. This I think is the doc start. And we need a doc start for this is at the beginning of the file, and for each record we need a doc start. After each record we need a doc start. Okay, so since we have a count 10, maybe we can make this count like if someone wants 2 sentences or 2 records from the training set as a single record. Okay, so let's add a doc start on count. We'll just copy yank this line, copy this and paste it here and indent it properly. Okay, so now we have this. Let's see. Let's go to first line. Yeah, so we have a doc start. Oh, so we have our count 10, right? So we'll make it 1. count is greater than equal 1, and then what we can do is count equals 0, and then what we can do is remove the sys.exe. I think we are done with the code here. Yeah, this, let's add an empty line. This will convert the entire file. Let's see. Let's see, is our code correct? Yeah, so there are doc starts. Okay. यह सूर्य ग्रहण भारत में भी दिखेगा. There is some problem of rendering Hindi in my terminal. I'll fix that later. Okay. So we have this. Let's rename it to like Hindi underscore train.iob. So similarly, we can convert our validation to Hindi underscore val.iob and underscore test to Hindi underscore test.iob. Right. So now we have our three files, which is our train, validation, and test. Okay, all right. So what's our next item? So, I forgot to move these. So we are done with introduction to dataset. We already downloaded the dataset, and we are done with that as well. We have converted the dataset to IOB format. Okay, fetch 15k records for training. Okay, so I have experimented with this dataset before, and my graphics card, which is an RTX 3080, which has around 10 GB of RAM, almost gets full with 15k. So if I experiment with more data, it tends to shoot out of memory. So 15k is a good amount of data to train, and good amount of data to see in this video demo. Okay, so now we have our Hindi train.io. So let's see the number of lines which we have in our. Okay, so we have these many lines. Okay, so let me grep for doc starts, because those are the number of records which we have. So we have doc start in Hindi. Okay, so we need line numbers. So let's see, grep help, and here -n prints the line number. Okay, so let's try grep -n doc start, and here we get the line number. Okay, so what we need is to match 15,000 doc starts. So let's see on the grep help how to match. Here it should be minus m, stop after number of selected lines. So let's make the max count as how much it should be, 15,000 doc starts. Okay, so this is 32301. So this is the 15,000th record. So maybe we need 15,001. Okay, 382317. So 382316 is the end of the last 15,000 records. So what we would need is 382316 lines from in the NAIO train.iob, and what we can do is put it into Hindi train underscore 15k.iob. Okay, let's see how big is this. It's 5.2 MB. Let's check this 15k. It would be the same. Oops. 15k.io. Cool. So we have that. Okay. So we are done with this. Okay, introduction to Acharya MLops. So what I have found is there is an Acharya MLops tool here. This tool helps manage the NER data, NER training data, and any complete. It helps manage your named entity recognition projects, and it is fairly easy to use. So I've gone through this and I've tried it with my data set. So here on Acharya 0.3.3 alpha, let me go to the release here and download for Linux. Okay, let me copy link address. Okay, let me open my terminal. Here I can maybe I'll create an Acharya folder. Okay, cd Acharya. Now let me just download the release. It's Linux. It's downloading. Okay, meanwhile let me pull this. Where is our data set? Okay, inside data set, let me pull this data set to my machine. Okay, cd scp -rp2 Ryzen RTX 3080 Ryzen 9 from this machine to Hindi NER / data set / star.iob. Okay, so now we have our data set here, and we'll go to the Acharya folder, and we will, okay, let me chmod, let me allow execution permissions to this file. Let me start. Okay, so now this is available on 3000 port. So I'll open RTX 3080 Ryzen 9 colon 3000. Okay, here it's asking you to set a password. I'll set a password for admin at localhost. Okay, save password, no. Start a tour. I don't need a tour now, so let me create a project. I'll name it Hindi 15K. Okay, and I'll name it Hindi first 15K records for training, downloaded from AI for Bharat, naamapadam de India data set. Okay, let's submit. So we have our project created. Let's upload data over here. Just let me go to my folder which I created just now, and yeah, and then I will check the 15K train file here. Oops. It should be, okay, let me change it to IOB, and then I think the Brave browser is not supporting drag and drop. Okay. No, it's not supporting drag and drop. So just allow me to upload this file offline from the recording screen. Okay. Okay, we are back. Okay, maybe I can, I selected this 15K 5.4 MB. Okay, and this is upload name is training, training 15K. Tags is AI for Bharat, Hindi. Yeah, no, that's okay. This is for training, and upload. Okay, so we uploaded 15,000 records into Acharya. Similarly, let me select validation and test, both of them as evaluation records, and let's make it eval upload. Yeah, so 13,897 records are there for training and evaluation. So let's go to our dashboard. Okay, so here we have 28,897 records, of which 51% is training and 48% is evaluation. So I think they're showing all the records here individually. Okay, here we have org, like 23,501 footprints of org in training and 21,752 footprints of org for evaluation. Similarly for person and for location. Okay, let me change the colors. While I'm here, let's choose green for org, or yeah, or maybe maroon for org. Yes, and choose person is orange, right? Let's choose lime for person and choose yellow for location. Okay, so in this we also see that there are some reports which are shown like multi-classification. So here it's showing that the word Bhajpa has been classified as a location in one instance, as an org at 488 instances, and that as a person in one location. Okay, here they are. Okay, so let's check the other. Here misclassification, it's showing that this pipe, or maybe it's a full stop is classified in one record and missed in these many records. K has been classified in 14 records. Let me expand K. Okay, K has been classified as a person, as an org, as a location, and missed in so many records. Okay, we'll come to it, and there are anomalies like this. So it's saying the classification is beginning with a dot character, the classification is beginning with a comma character, and then there are unclassified words, and we don't have any algorithm strain, so it's not showing anything here. So let's go to our workbench. Yeah, here it says no algorithm strain, turning off evaluations. Okay, there are some words which are highlighted in red as spelling mistakes. So I've been told that these are suggestions, where if a word is classified in any of the record, it will be shown as a suggestion here. So like if I see is, the word is has been classified as a location in these two records, so it's showing a string suggestion here. So I can turn off the suggestions and I can read this record. So here it's saying sector 5556K SHO अरविंद कुमार ने बताया कि इस मामले में आईपीसी की धारा मामला दर्ज कर लिया गया है. Okay, so let's see our record. How is it? Okay, let me open the in the NER. We have a data set. Let's check our train.json. Okay, let me enable line numbers. So first is sector 5556. So here we see that Arvind Kumar is a person, begin person, immediate person. Here also Arvind Kumar has been marked a person. Let's go to record 2. So here it says Madhya Railway evam Paschim Railway. So it's B org, I org, I org, I org, I org. So it's B org, I org, I org, I org, I org. So Madhya Railway evam Paschim Railway has been marked as an org. So here it's Madhya Railway evam Paschim Railway. अधिकारियों के अधिकारियों के अनुसार मनमाड. Here मनमाड. Okay, मनमाड is, let's see. Okay, let me adjust this so that the words and the NER just match. Okay, so here Madhya Railway एवं पश्चिम रेलवे के अधिकारियों के अनुसार मनमाड is not marked, hyphen is not marked. Mumbai begin org, express I org, comma not marked. Gujarat begin org, express I org. Saurashtra express. Okay, so Mumbai express, Gujarat express, Saurashtra express, Bandra terminus. Cool, so this looks correct. Sivan K, जाने माने वैज्ञानिक Sivan K. So let's see here. जाने माने 0, वैज्ञानिक O, sorry O. Okay, जाने, correct. Hyphen is 0, माने is 0, वैज्ञानिक is O. Sorry, I'm I'm pronouncing it 0. It's O. Sivan is begin person, K is I person. भारतीय अंतरिक्ष अनुसंधान संगठन ISRO. Okay. Okay, so our data set looks correct. So let's fix the data set in a later. So let's see what is our to do. Okay, so we are done with introduction to Acharya MLops. Download and run Acharya we already did. Create project and upload data we already did. Check the uploaded data in dashboard, again we did. Okay, now let's go to add an algorithm. Okay, here, so this part is the fairly confusing part right now. I think it's being developed. So if I go to add new, it just gives me this. Here if I do something, it says IOB and details, default value, and get and default value. So this is something. So I've been told that the Acharya developers have some like starter templates, so we can start. So let's go to the template. Here they have this SPACY template. So but before that, let's see what all we need to train a SPACY model using like on Hindi dataset. So let's go here. So let me take this up here. check spaCy side. Okay, let me do a train spaCy model. Okay, so here if we go, it says quick start. So here what we have is an NER, and we are using GPU, and we need to optimize it for accuracy. So it's giving us a config, a base config. And here what we can do is we can change the language to Hindi. So here in the config, the language has changed to Hindi. So this you can save as a base config. So I've been told that here in Acharya spaCy, and under the spaCy Hindi NER branch, there is a base config. So the base config is here they have Hindi, and then they are using the AI for Bharat. I think they are using the AI for Bharat Mbert module. Okay. So the next step is, after we have this config, they are saying to fill the base config with, like, fill the starter base config with the other remaining configurations to build a config.cfg. So these, they would fill the default configuration so that spaCy's module gets all the configuration which it needs, and the users need not work on the entire configuration set rather than a small subset of configurations. Yeah, so here, right here, so they are using the AI for Bharat Indic BERT model as a base language model. I think here also it should, yeah, here. Now what there is then the next step is to train the spaCy model with the configuration and the data. Okay, and now there is that's it. This is the steps for training spaCy model. So here what I'm told is they have this base config, and then what they have is a train.sh. So train.sh is basically the script which would be run by Acharya when you initiate a training. So when we open this, it's like what it does is it converts the kernel or the IOB data file to spaCy docbin format. So it says convert data to kernel. Okay, and then what they are doing is they are running this same command which is given here. Okay, it's here. Yeah, and then they are beginning training here with the same command, almost similar command. So what the training is Python module spaCy train, and using this config file, the output is to the models folder, and the train path is this train file.spaCy. I think it's built on line number 5, and the dev path is again the same file and using a GPU, and once it's done, the training is done. Okay, so in the starter model they have given and they have mentioned that the evaluate model.py is called for evaluations. So over here what they do is apart from the basic logging stuff, what they do is they load the best model train under the models folder, and then they have some code which they convert we'll come back to here. What they're doing is accepting a socket connection, and once they get their data in binary format, they do decode the binary data to UTF-8 string, and then NER eval record. Yeah, so they are just building the record and as text, and then evaluating. Oh, they are converting the kernel format to string data and evaluating and getting the labels from the trained model and converting into Acharya. So I'm told that there is a feature in Acharya where like the labels are not stored. Okay, the labels are stored with an ID rather than the name, so that tomorrow you can modify. Like here I can modify this lock to something else, but then our trained models need not be changed. We need not do a retraining because the model has been trained with an ID, and then there is this conversion step which happens where you just need to convert that ID to the label which you want. So that's what is Acharya label this thing is. That's it. So this is the evaluation model. So the training is simply this. Evaluation, this is simply loading the model and just doing NER, like how the classic SPACY model works. And then the Acharya, I'm been told that Acharya runs the algorithms inside a Docker. So there's this Docker file. So my system is running CUDA 11.4.2. So this is what the image is being used. Okay, it's a very small Docker file, and then there is this algo configuration.yaml, which is what we put it in. Oh, what happened? Something went wrong. I'll just copy this. Okay, which we need to put it in the UI. Requirements.txt is the pip requirements to train this model. So let's go to our UI, algorithms, add new, and just paste it here. And this is what it is. So it says that the data format is kernel 2003, run on Docker. So I've told that Acharya can convert, like once you upload a data in Acharya, Acharya can convert the training data into any format which your algorithm needs. So if your algorithm is trained on an IOB or IOB2 or IOBES or BILOU or kernel 2003 or a JSON-L or maybe a TSV, you can ask Acharya to convert it. So here the Acharya SPACY code which is written here, it's expecting a kernel 2003 data format. So here we are converting it to kernel 2003, and these are all the details of the ports which will be exposed by the Docker. Here the Docker host is localhost where the Docker server can be accessed. So if you are connected over VPN, you can give any server machine which you might have access to instead of localhost. And I'm told that right now it only supports Docker connection via TCP. And then runtime NVIDIA is to use the GPU support which the Docker offers. And this Acharya can automatically pull the algorithm from a Git server. And if you give your Git path and Git authentication token, here currently it's none, and the branch name, it will pull this repo. It will automatically pull this repo and build a Docker file, and then start training and evaluation inside that Docker file. Okay, so this config.yaml is what Acharya looks for when doing training and evaluation. So here inside config.yaml, what it says is, it says Acharya that to train, there is a command which is this, and it expects input in this particular file, and the output would be given on standard output. And for evaluation, this is the command, and it's a type service, so it's a daemon service, and the input would be on TCP port 5566 and the output would be on TCP port 5566. Okay, so that's it. So let me save this, and then let me go to training, yeah, and do a new training and select this and start the training. Okay, so here the Docker would be composed and then the training would be started. So here I can see the training logs. I can go down. So here the Docker has been composed. So I have run this before in this machine. So the Docker pull of the NVIDIA image and all, it had already cached, else it would take some time to pull. So now the training is running. So let me go to my terminal and see my NVIDIA SMI. Here right now I'm using around 1 GB of my 10 GB RAM. Let me do watch on 1 second. Yeah, and let me also show you that there's Docker PS. So there's this Spacey Hindi CUDA about a minute ago, which container has been spawned by Acharya. Yeah, so now it's around 3 GB of memory is being used. Okay, around 3.84 GB has been consumed. Around 5 GB RAM has been consumed. Okay, 6 GB. Now it's 7 GB, and now it's 8 GB. Hope it just stops around 9.5 GB, because yeah, this is what I observed last time as well. So the training has started. It's stable around this 8.4 GB. So if I increase the number of records to like 20,000, I am just on borderline. Sometimes it goes out of memory. So then I have to experiment with the batch size. So this 15K works out of box with default settings. So this is fairly good. 15K records is fairly good number of records to train on, and we'll see what's the accuracy score and how to improve on it. Okay, so this takes around 1.5 to 2 hours, this training. So while this runs, let me show you the output of my previous training. Okay, let me open. Try this in the it's test in the yeah. Okay, so let me run so let me run port equal 3500 and dot / Acharya 3.3. Okay, so that Acharya instance is running on port 33 now. I would need to enable access, a firewall access here. So let me just do it off screen, off the record screen. Okay, I'm told that my firewall rules are accepting all ports from this machine to that machine. So let's see, RTX 3080 Ryzen 9:3500. Yeah, so this is the project which I had done the training on, and it's training 11, and this was on the 15,000. So just ignore this because there was some problem with my power electricity here in this location, so this got skewed, but it actually takes around 1.5 to 2 hours to train. And for the 15k records, the score came out to be 53%. So if I expand this, so the F1 score was 0.7 and recall was again 0.75 with a precision of 0.66. So and in the reports, if you see it shows the per entity score. So for location, the F1 was 0.76 with a precision of 0.717 and a recall of 0.8 and a score of 61%. And for org it actually dropped a lot, and for person it's around 59% with 0.7. So the precision and recall in org actually dropped a lot. So I think there is, though org has the largest number of footprints, so here if we see, org has the largest number of footprint in terms of presence of marked entities, yet its training score is fairly low. So here I get to see this. So it also shows per record score as to which record. So here I can sort on score. So here the record 15037 scored a -100. Like, I think there is some problem here, but it was the least performing evaluation record. And if I saw like 28894 scored a perfect 100. Yet there was a true positive. Let's open the records, the said records. Or let me open 28894. Okay, Kangana Ranaut फिलहाल अपनी film. So Kangana Ranaut has not been marked as a person, or maybe it was marked and I changed it by mistake. And 28886 28886 is the worst performing record. प्रधानमंत्री ने कहा श्री मदन लाल खुराना जी के निधन से वे दुखी हैं. So I think this G should not be in person. It's like only Madan Lal Khurana should be marked as person. Okay, so let's evaluate these in a future video and see how we can improve this score of 53% using data-centric approaches. So let's go to our agenda. Yeah, here we check this. We added an algorithm, we explained this basic CUDA, we ran the training, we showed a previous training output. Okay, these all are done. Oops. Okay, now it's showcase the model suggesting on new data. Yeah, so here let me search for some Hindi movie Wikipedia entry. In the Wikipedia, so that I don't have in the Wikipedia. Okay, here I can go to let's see this. Okay, let's copy all of this and see how the stop auto refresh. Okay, let's see how the training, like how the 53% accuracy model performs on that data. So here I'll go to upload and then text format, and I can add data from the internet here, and I can add text as a record, and I can give them a news from Wikipedia. Just for the sake of it, I'll upload the data. There is one record. We'll go to dashboard. I think this is the data which has been uploaded. I'll open it. Okay, so when I added a new record, so this is how it looks in workbench. So because our data is not clean, this K and poor all are being highlighted. Let me turn off suggestions here, the string suggestions. Now what this is doing is it's evaluating this particular data with the best trained algorithm we have. But right now the best trained algorithm is this Spacey Hindi NER CUDA. So that algorithm is saying that for this record, Japan is a location, Shinzo Abe is a person, and Kabul has not been marked as a location. Okay, Israel has been marked as a location, which is correct. Baghdad ke Ibn al-Khatib Hospital, it could be an org, or maybe मैं आग लगने से, so this could be an org, this should be an org. Saint Vincent and Grenadine के law, so this should be a location. ज्वालामुखी में विस्फोट होने से. Sri Vijay Air Udan. Okay, so let me take a screenshot of this and let's compare when we will improve the accuracy of. Well, I don't need a screenshot because I will not touch this particular project again, so I can upload the data anytime here. So here in this workbench, if I click on this, it will mark it as an entity. And so I've been told that with this you train with some record. Like if you are building a custom NER model, you upload say 100 or 200 record, maybe from a data set, and then train your base NER model and use that to help your annotators. And then something which has been missed by this algorithm, you can mark it by hand. ऑफिसर ज्वालामुखी में विस्फोट होने से निधन भाषण के दौरान काबुल के एक स्कूल के नज़दीक बम विस्फोट होने से लगभग घायल हुए. इजराइल के माउंट मेरन में. दिस शुड आल्सो बी अ लोकेशन होने के कारण कम से कम और अधिक लोग घायल हुए. आग लगने से लगभग. श्री विजय एयर उड़ान. what is Sri Vijay Air Udan? Sri Vijay Air Udan 182. Sri Vijaya Air Udan. It's an org. Boeing Sri Vijay Air. Yeah, it's an org. So let's mark here. Sri Vijay Air Udan. Like this. So this is how this particular product helps in quickly building your custom NER model. So let me go to some other. We can try one more. Maybe some entertainment news. Where can I get some entertainment news? सहायता अक्सर पूछने वाले अनुरोध दान करे. हाल की घटनाएं. Let's go here. यूनान के अंतिम राजा जेसिंडा आर्डन ने will there be some New Zealand cricket team? There could be. इतिहास संदर्भ. न्यूजीलैंड. उपकरण. Enter. Let's see Bollywood. Yeah, that's it. Let's see Amitabh Bachchan. Pramukh. And someone whose movie has been launched recently. Yeah, there should be some news. Okay, let's use this. Copy. Come here, go to upload, add a text. Let's remove all this 12. Okay, next is something from here. Shahrukh. What's this? Oh my god, that's too much. Let's not put too much data because then we will have a problem. Yeah, so let's remove this. And that will be. Okay, is there any news? संदर्भ ग्रंथ सूची श्रेणियां okay just let's upload it. Let's go to dashboard, the last record, open it. Yeah, so here let me turn off suggestion. Amitabh Bachchan has been marked as a person. Harivansh Rai Bachchan has been marked as a person. Shah Rukh Khan, Bollywood has been marked as a location. Cool. So even with 53%, see this tagging, it's helping tagging on the person, because we saw that for person the score was actually 71% accuracy. So for org it's low, and that's why I think org has not been marked as correctly. So let me turn on suggestions. So here Bharatiya film should be an org. Bollywood should be a location here, right? So this should be an org. This should be a location. अभिनेता और प्रसिद्ध हिंदी जिन्हें अक्सर करो और अनौपचारिक रूप में एक भारतीय फिल्म अभिनेता है। अक्सर मीडिया में इन्हें बॉलीवुड के बादशाह किंग खान, रोमांस किंग और किंग ऑफ बॉलीवुड. This can also be person, right? King of Bollywood. Yeah. So this is how this tool helps in creating quickly your own customized data. So let's look at the progress of our training. Okay, let me go to the tab. Yeah, so it's still using around 8.5 GB of RAM, and it's still, the training is still in progress. So it takes around 1.5 hours. So I'll end the stream right here. We'll come back in our next episode to see the output of this training, as well as how we can improve upon the data set so that we fix these anomalies, we fix some classification errors, and we fix the misclassification. So like Modi has been marked as a location. So these are all kind of errors which we can fix using these data-centric reports. Like this full stop has been marked as and location on record 975. I'll just open this. Yeah, here full stop has been marked as let me toggle highlight. Yeah, full stop has been marked as a location on line record 975. Let me open that in our data set. Let's verify it. In the NER. So let's open Vim. In the NER, no, we have high underscore train JSON, and we'll go to red line. Let me enable line number and line number 975 because we took the first 15,000 records, so our record numbers and the line numbers here should match. So here if we see this record, the last word is full stop, and in NER the last tag is B locations. Yeah, so this is definitely annotation error by the human annotator. So we will fix this in these kind of issues in the next coming episodes and see how we can improve upon the score of 53%. Okay, so we did showcasing the model suggestion also. So that's it. We have covered all the 15 items for this particular episode of developing data-centric Hindi NER model. So thank you for being patient and watching it. Do comment the suggestions and mistakes which I may have made so that I can rectify it in future videos, and do let me know what all would you like to watch and I could focus on that. So thank you so much, and let's meet in the next episode. Bye, take care, have a nice day.